Assalamualaikum and good morning. We are from Group 3 and our experiment is titled Head Loss in Pipes Due to Friction. And now, let me introduce you to our group members. First of all, it's me, Muhammad Hafiuddin bin Ruslan. Second, Muhammad Johan bin Kalimi Johan. And lastly, Muhammad Wafi bin Muhammad Said. In a real pipe system, water loses energy as it flows through a pipe. This energy loss happens due to friction between the water and the internal wall of the pipe. If the pipe is rougher, the resistance becomes higher and can reduce flow efficiency and increase pump power requirement. This is important in engineering because high head loss can reduce flow efficiency and increase pump power requirement. The objective of this experiment is to determine the head loss due to friction in pipes at different flow rates. We also compare the head loss between two smooth pipes and one roughened pipe to observe the relationship between flow rate and head loss. The basic concept used in this experiment is pressure difference. The upstream pressure is represented by H1 while the downstream pressure is represented by H2. The pressure difference is calculated using H1 minus H2. Since our reading is in SI, the head loss is calculated by multiplying the pressure difference by 0.703 to convert it into meters of water. In general, when the flow rate increases, the velocity of water also increases. Therefore, the head loss due to friction also increases.
In this experiment, we tested three different pipe parameters. The first pipe was a roughened pipe with an internal diameter of 16.4 mm. The second pipe was a smooth pipe with an internal diameter of 9.2 mm. And the third pipe was another smooth pipe with an internal diameter of 6.8 mm. The reason we use three different pipes is to compare how pipe roughness and pipe diameter affect head loss. The roughened pipe represents a pipe with higher internal surface resistance, while the smooth pipe represents pipes with lower surface resistance. The two smooth pipes also have different internal diameter, which allows us to observe the effect of pipe size on friction loss. For the method, the selected pipe was connected to the apparatus and water was allowed to flow through it. The flow rate was adjusted using the control valve. For each flow rate, the upstream pressure reading H1 and downstream pressure reading H2 were recorded using the pressure gauge. The same procedure was repeated for three different flow rates for each pipe. This gives enough data to compare the head loss trend for the roughened pipe and the two smooth pipes.
Now, let's move to the apparatus for this experiment. First of all, we have the main switch. And then we have pipe friction apparatus that connected with pressure gauge and tube. We also need flow control valve and digital flow meter. For the pressure gauge, we don't want bubbles in our tube. So we turn on the valve and remove the pressure gauge from its tube and drain out the water from the pipe to remove the air bubbles. As we can see here, the bubble has been removed. And last but not least, we also need to measure the length of pipe friction apparatus using ruler.
Now, for the procedure, we turn on the power switch, we open the pipe valve, we open the pressure gauge valve. Now, we open the control valve to determine our discharge using the flow meter. Now we can read the pressure from the digital pressure gauge. The flow rate was then adjusted to different values and the upstream and downstream pressure readings were recorded again for the same pipe. After completing all readings for one pipe, the pressure gauge tube were carefully detached and connected to the upstream and downstream tapping point of the next pipe sample. The same procedure was then repeated for the new pipe. After all the readings were recorded, the head loss due to friction was calculated using the pressure difference between upstream and downstream pressure readings. The upstream reading is represented by H1, while the downstream reading is represented by H2. Therefore, the pressure difference is calculated using delta P equal H1 minus H2. For the sample calculation, we use the smooth pipe with internal diameter 9.2 mm at flow rate 16. The upstream pressure readings H1 was 10.1 psi, while the downstream pressure readings H2 was 3.8 psi. So, the pressure difference is delta P equal to 6.3 psi. Then, the head loss is HF equal to 6.3 times to 0.703 is equal to 4.43 meters. Therefore, the head loss for this reading is 4.43 meters. The same calculation method was repeated for all the other readings. Based on the results, the roughened pipe with internal diameters of 16.4 mm produced head loss values of 3.37 meters, 2.95 meters, and 4.15 meters. For the smooth pipe with internal diameter of 9.2 mm, the head loss increases from 3.94 meters to 5.20 meters. For the smooth pipe with internal diameters 6.8 mm, the head loss increases from 3.45 meters to 4.64 meters. From this result, the head loss generally increases as the flow rate increases. This is because higher flow rate causes higher water velocity inside the pipe. When the velocity increases, friction between the water and the pipe wall also increases, causing more energy loss. The results also show that head loss is affected by pipe roughness and pipe diameter. A roughened pipe creates more resistance because of its rough internal surface. At the same time, a smaller pipe diameter can also increase head loss because the water flows at higher velocity. However, for the roughened pipe, the second reading shows a slight inconsistency because the head loss decreases even though the flow rate increases. This may be caused by experimental errors such as trapped air bubbles, unstable flow, pressure gauge fluctuation, or readings error. This experiment is related to SDG 9, Industry, Innovation and Infrastructure in Rail Engineering. Systems such as water supply pipelines, drainage system, and pumping systems, head loss must be considered during design. If the head loss is too high, more pump power is required, which increases energy consumption and operating costs. Therefore, understanding head loss helps engineers design more efficient and reliable pipe systems. Choosing a suitable pipe diameter, smoother pipe material, and better pipe layout can reduce friction loss and improve infrastructure performance. In conclusion, this experiment successfully determined the head loss due to friction in smooth and rougher pipe. The result shows that head loss generally increases when flow rate increases. The experiment also shows that pipe roughness and pipe diameter are important factors affecting friction loss in pipe flow. With that, marks the end of our presentation on experiment head loss due to pipe friction. Thank you for watching. Bye.